Welcome to Cosmic Compass, the channel where we navigate the mysteries of the universe together. Out there, beyond the thin shell of our atmosphere, lies a cosmos filled with wonders, planets, stars, galaxies, and questions that stretch the limits of human imagination. Here we don't just talk about space, we journey through it. We ask big questions, explore the evidence, and discover how our place in the universe is revealed by the skies above us. Whether it's the story of a lone rover on Mars, the secrets of distant worlds, or the ancient clues written in the stars, together we'll uncover the science that shapes our cosmic perspective. So let's take a step back from our everyday lives, look up at the night sky, and set course for discovery. This is Cosmic Compass. Most of us take it as an undeniable fact. The Earth is round, orbiting around the Sun. But let's pause for a moment. If someone were to sit you down and ask, how do you know this without using photos from space agencies or advanced satellites, would you be able to answer, for example, from a commercial airplane window, even at cruising altitude, you won't clearly notice Earth's curvature. To truly see it, you would have to be more than 40,000 feet high, higher than most flights you have probably taken. So, how do we actually know the Earth is round and not flat? And more importantly, how do we know that Earth orbits the Sun rather than everything orbiting us? Even today, there are communities of people who passionately defend the flat Earth model where the Earth is imagined as a flat disk and the Sun simply circles above it. Throughout history, the geocentric model where the Earth was believed to be the center of the universe was widely accepted. This idea dominated human thought for thousands of years. Yet, remarkably, some ancient civilizations proposed something different, a heliocentric model in which the Earth is a sphere orbiting the Sun. They had no telescopes, no space probes, no satellites, so how could they possibly arrive at such a conclusion? In this video, let's journey together into the observable world around us. We'll examine simple yet profound clues that anyone can see from Earth, clues that reveal our true place in the cosmos. To set the stage, let's first understand where Earth fits in the grand cosmic architecture. Earth itself is a roughly spherical planet, held together by the force of gravity created by its own mass. The Moon, our closest neighbour, orbits Earth, while Earth in turn orbits the Sun along with a family of other planets. Together, they form the solar system. The solar system is dominated by the Sun's immense gravity, and around it circle worlds of every kind, gas giants, rocky planets, moons, comets, and asteroids. And the Sun itself is not alone. It is just one star among hundreds of billions in the Milky Way galaxy, which in turn is just one of billions of galaxies scattered across the observable universe. But what matters most for us is this Earth is not at the center. Earth is one world among many orbiting a star, which itself orbits within a galaxy. The heliocentric model is our best explanation for this arrangement, supported by centuries of observations and experiments. So the question becomes, what are the direct visible signs here on Earth that prove this picture is real? Let's explore them step by step. Let's start with the Sun, the most obvious celestial object in our sky. If you were to measure its angular diameter, the angle it spans, in our view, you would find it to be roughly half a degree, or about 30 arc minutes. What's fascinating is that no matter when you measure it, morning, noon, or evening, the Sun's apparent size stays nearly the same. Now, why does this matter? In the heliocentric model, this makes perfect sense. The Earth orbits the Sun in an ellipse, but the distance only changes by about 3% throughout the year. That small variation is not enough to change the Sun's apparent size in any noticeable way. But in a flat Earth model where the Sun supposedly moves in circles above the surface, the distance from the Sun to an observer would vary dramatically during the day. At noon, it would be closer. At sunrise and sunset, it would be farthest away. If that were true, the sun should appear much larger at noon and much smaller on the horizon. Yet in reality, something quite different happens. Sometimes the sun actually looks slightly larger near the horizon than overhead. That effect is due to atmospheric refraction bending the light and distorting our perception. Far from supporting a flat Earth, it reinforces the idea that the sun remains at a fairly constant distance. So just by observing its apparent size, we can confirm the sun is far away and Earth's position around it is stable. Next, let's turn our attention to the planets. These wandering lights in the sky puzzled ancient astronomers for centuries. Unlike the stars, they don't stay fixed. They move sometimes in unexpected ways. Take Mars, for example. Most of the time it drifts steadily eastward across the night sky. But at certain points in our year, something strange happens. It appears to slow down, stop, and move backward before resuming its forward motion. This phenomenon is called retrograde motion. If Earth were the centre of everything, such behaviour would make little sense. Why would Mars suddenly reverse direction? But in the heliocentric model, the explanation is straightforward. Earth orbiting the Sun closer and faster than Mars occasionally overtakes it. From our moving perspective, Mars appears to loop backward, much like when a faster car on a highway overtakes a slower one, the slower car seems to move backward relative to you, though both are moving forward. Now consider Venus. Unlike Mars, Venus orbits between us and the Sun. This creates another visible clue phases. Just like the Moon, Venus displays crescent half gibbous and full phases depending on its position relative to Earth and the Sun. Through a telescope, you can see this directly. And as Venus changes phases, its apparent size changes to larger when it's closer, smaller when it's farther away. If Earth were the centre of all motion, Venus would not show these dramatic changes, but it does. Its phases are a clear fingerprint of a planet orbiting the Sun. So the planets themselves, these wandering lights in the night sky, are powerful witnesses. They reveal not only that Earth orbits the Sun, but also how other planets move in harmony with us. Now let's look further out at the stars. To the naked eye, the stars appear fixed, eternal. But if you take long exposure photographs or simply watch the sky over several hours, you'll see they move in arcs across the night sky. This motion is not because the stars are revolving around us. It is because Earth is rotating on its axis. A time-lapse pointed at the North Star Polaris reveals beautiful circles of light, all centered around that fixed point. In the southern hemisphere, a similar pattern emerges centered on the southern celestial pole. And here's something even more striking. Depending on where you stand on Earth, the stars visible to you change. From the southern hemisphere, you will never see the North Star. From the northern hemisphere, you cannot see the Southern Cross. If the Earth were flat, every star should be visible to everyone everywhere, but they're not. This difference in perspective tied directly to your latitude is further proof of Earth's spherical shape, and the graceful sweep of stars across the sky night after night confirms Earth's rotation. Another striking clue lies at the extremes of our planet, the poles. At both the North Pole and the South Pole there are times of the year when the sun never sets. This is called the midnight sun. A flat Earth model might account for the North Pole, but it cannot explain the South. How could the sun illuminate all of Antarctica at once if it were circling above a flat disk? The reality is far more elegant. Earth is tilted on its axis. During summer in the northern hemisphere, the North Pole leans toward the sun, remaining in daylight for months. 6 months later, the South Pole takes its turn. This axial tilt also explains the seasons we experience everywhere on Earth. As our planet orbits the sun, different hemispheres receive more direct sunlight at different times. That is why summers are warm and winters are cold. And this tilt affects not just the daylight, but also the stars we see. For example, at 8 p.m. in February, the constellation Orion might not have risen yet, but at 8 p.m. in August, Orion is already high in the sky. Our view of the stars shifts with the seasons, another elegant piece of evidence that Earth orbits the Sun. Together, the midnight sun and the cycle of seasons weave a consistent story. Earth is tilted, rotating and revolving around the Sun. Of course, today we no longer have to rely solely on ancient observations. Modern technology has given us direct proof. Satellites orbit Earth, cameras on space probes send back breathtaking images, and the International Space Station streams live video as it circles our planet. In fact, you don't need to travel into space to witness this. With the right timing, you can step outside and watch the ISS streak across the sky like a bright star in motion. Some photographers have even captured it in detail, silhouetted against the sun or moon. These modern tools confirm what human curiosity and careful observation had already revealed long ago. But they also remind us of something important. The truth about our world was written in the sky, waiting for anyone with patience and curiosity to discover it. So how do we know the Earth is round and orbiting the Sun? The evidence is everywhere. It's in the unchanging size of the Sun, the curious backward loops of Mars, the shifting phases of Venus, the circling arcs of the stars, the endless daylight at the poles, the changing of the seasons, and the modern images streaming back from space. We don't need to take it on faith or trust technology alone. With a little effort, you can step outside and see these signs for yourself. Look up at the stars. Track the movement of a planet across the sky. Watch for constellations returning with the seasons. These are the same clues that guided thinkers thousands of years ago to the conclusion we now hold as fact. Earth is a sphere part of a solar system orbiting a star in a vast galaxy. So let's not forget to look up. Let's continue to explore, to question, to observe, because in doing so we not only confirm where we are in the universe, we also rediscover the wonder of being here at all. Ati. And if you enjoyed this journey, stay curious, share it with a friend, and join us again next time on Cosmic Compass. As we've seen today, the universe offers its answers openly to those who are willing to look. Every sunrise, every season, every star above us is part of a greater story, a story that connects us to the cosmos itself. Here on Cosmic Compass, we'll continue exploring these stories one journey at a time, because understanding the universe is not just about science, it's about perspective, wonder, and our shared curiosity. If you found value in today's journey, let's keep exploring together. Share this video with a friend who loves to wonder, give it a like to support the channel, and don't forget to subscribe so you don't miss the next step in our cosmic adventure. Until then, keep your eyes on the stars, your mind open to questions, and your compass set to curiosity. See you next time.